Hello students, in lesson number 8, we were doing the exercise numericals. So further, question number 4. See the question. A motorboat starting from rest on a lake accelerate in a straight line at a constant rate of 3 meters per second square. Okay, so starting motorboat starts from rest. It means if this is the keyword, right? And accelerate, it means it changes the velocity in a straight line at a constant rate of 3 meters per second square for 8 seconds. How far does a boat travel during this time? So during this time interval 8 seconds, how far the boat has traveled? It means how much distance it has traveled. So what is the data given here? U is equal to 0. Why? Because the boat is starting from rest. Okay, so this is keyword indicate that it is the initial velocity is 0 because it starts from rest position. Okay, so U is 0 and it will accelerate at 3 meters per second square. 3 meters per second square is a unit for acceleration A. Okay, so it means that it is A given. A is equal to 3 meters per second square. Is it positive or negative? From 0 the velocity will increase. So for increase of velocity we have A positive. So we will take A as plus 3 meters per second square and time is 8 seconds. What is the distance travelled by the boat? So S we need to find. Distance travelled S is equal. We have for distance two formula. First is S is equal to UT plus half AT square. Let us check. We have U, yes. T, yes. A, yes. T, yes. So we have all the quantities, we can use this formula. S is equal to UT plus half AT square. Put the value, U is 0, T is 8 plus 1 upon 2 multiplied with A, that is 3 and T square, so 8 into 8. All are in a standard unit? Yes, meter per second square and second. 0 into 8, 0 plus, we can cut here. This 2 will cut with 8, 2 4s are 8. Now 3 4s are 12, the legs are 96. 0 plus 96, 96. And it is a distance, the unit will be meter. So distance travelled by the motorboat during this 8 seconds is 96 meters. Right? So simple. Now next, which is a very important question. Question number 5. Very important question. See the question. A driver of a car traveling at 52 km per hour. Okay, a car is traveling at 52 km per hour. Applies the brakes and accelerate uniformly in the opposite direction. Okay, when you apply the brakes, acceleration is always in the opposite direction. That means negative. The car stops in 5 seconds. So let us say the car 1 is car A and another driver going in the another car going at 3 km per hour applies his brake slowly and stops in 10 seconds. So here we are talking about two cars. Let us say car A and car B. For car A, it is traveling with 52 km per hour. So its initial velocity is 52 km per hour. Okay, and time given in seconds. So we need to convert this kilometer per hour to meter per second. How do we convert? By multiplying with 5 by 80. So 52 into 5 by 80. So we can cut it. 26 to that 9 to the 80. 26 into 5, 130 divided by 9. And if we divide it, it will be 14.4 meter per second. Okay. Now, same way for car B, it travels with 3 km per hour. In some of the books, there is a change in this velocity, but we will take this value 52 for car A and 3 for car B. Okay, there is a printing mistake and some other values are given for car B. Okay, so we are taking 3 km per hour. Okay, because most of the books have this value. So U is 3 km per hour for car B. So can we convert into meter per second by multiplying with 5 by 80. So it can be cut with 3 6 are 8, 80, 5 upon 6, which if we divide it, it will be 0.83 meter per second. And this car also stops in 10 seconds. So its final velocity for both the car will be 0, right? For first car, the time is 5 seconds, and for second car, the time is 10 seconds. First car stops after 5 seconds, and the second car stops after 10 seconds. On the same graph paper, plot a speed versus time graph for two cars, and which of the two cars traveled farther after the brakes were applied. So we need to draw the graph of the motion of these two cars. Okay. And we have to find the distance traveled after the brakes are applied. Which car has traveled more distance after the brakes are applied? Okay, so we need to find distance. But first we need to draw the graph of the motion. Okay, so take a graph paper and draw a graph of this motion. See this. So take a graph paper, draw x-axis and y-axis. The point of intersection is origin O. On y-axis we are taking speed and the unit is meter per second. So we have to mention the unit also, that when speed is taken in meter per second. And on x-axis we are taking time in second. Okay. Here we have to go from, for the first car it is 5 seconds and for the second car it is 10 seconds. So we need to go up to 10 seconds. Right? So we are taking a scale on x-axis as 1 centimeter equals to 1. So 1, 2, 3, 4, 5, 6 up to 10. Okay, up to whatever it takes. But we have the one of we have to use up to 10. So scale we can write scale of a graph. Okay, scale means for 1 centimeter how much measurement you have taken. So on x-axis we have taken 1 centimeter equals to 1 unit, right? 1 centimeter, that is 1 box indicates 1 unit. Okay, there is an increase of 1 every time. Now on y-axis we are representing speed. Speed is up to 14.4 and for car B it is 0.8. So we have to go up to 14 value. Okay, so we can also take 1 unit for y-axis. So y-axis also the scale is 1 centimeter equals to 1 unit. Now mention here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 14.4 it means in between 14 to 15 there will be the point. Now we have plot axis, now we have to plot a graph of the motion. See, consider here, whenever the observation starts, that means at initial point, here t is equal to 0, initial time means the time of observation. So when the car was observed, the car was initially traveling at 52 km per hour. It means 14.4 meter per second, car A. It means at initial time the car is at 14.4 meter per second. How do we represent 14.4? Between 14 and 15 there are 10 lines. So we will take after 14, 1, 2, 3 and 4. That represents 14.4 meter per second. Okay? Between 14 and 15 there are 10 lines. So that each line represents 14.1, 14.2, 14.3, 14.4, 14.5, 14.6, 14.7, 14.8, 14.9 and 15. Okay? In between there are 10 lines. So we will plot this 14.4 and 4 line above 14. Okay? So in between 14 and 15 there will be 14.4. Make a point. And now as the time passes, at 5 seconds, okay, 1 second, 2 seconds, 3 seconds, 4 seconds and 5 seconds, the car slow down. It means the velocity decreases. And at 5 seconds, the velocity becomes 0. It means the graph will be like this. The velocity decreases, decreases, decreases. And at 5 becomes 0 because y becomes 0 on x-axis. Interpret the graph very carefully, right? At initial time, the car is at 14.4 meter per second and it decreases, and at 5 it becomes 0. It means the velocity becomes 0. So this line represents the motion of car A. Okay, and this line represents the velocity decreases. Now for car B, what is the initial velocity? 0.83 meter per second. Where is 0.83 will be? Between 0 and 1? Between 0 and 1, again there are 8 lines. There are 10 lines, okay? Each represents 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1. So we will represent 0.83 where the 8 line 0.83 means 0.8 and 0.9 in between, but we will approximately take 0.8. Okay? So 0, here we will represent the 8 line above the 0. So that represents 0.8 meter per second. Okay? That is the initial point, and after 10 seconds the speed becomes 0. It means at 10 seconds the speed slowly it will decrease and it becomes 0. So this slanting line, this line represents the motion of car B. Okay, so this is the graph of the motion of two cars. Right? Alright. Now, the question is which of the car traveled farther after the brakes are applied? How can we find the distance traveled by the object from a graph? We have the formula that wherever from the graph we can find the distance. How? We have distance is equal to area enclosed by the graph. Whatever area is covered by the graph, that area gives the distance traveled by the object. Okay, so how much this area is covered by graph A? For car A, this is the graph. And how much area is covered under this graph? This portion. This whole triangle is the area under this graph, right? So we need to find the area of this triangle. The area of that triangle will give the distance traveled by the object. Okay, it is a right angle triangle? Yes, because the x and y axis are at 90 degrees. So this triangle will be the right angle triangle. And for right angle triangle, we have formula half into base into height. So half, what is the base? 0 to 5 means the base value is 5 and height is 0 to 14.4, which actually has the value 130 upon 9. So we will take height as 130 upon 9. Can we cut this? Yes. 65 into 130. 65 into 5. Multiply and divide with 9 will give 36.11 meter. Okay. So by taking the area formula, we can find the distance traveled by the object. Okay, for car A. And for car B, that makes another triangle. This is smaller triangle. How much area covered by this? Right? This much area. For car B, this is the graph. So area under this graph. Again, it is a right angle triangle. So S is equal to area enclosed by graph, which is the right angle triangle. So half into base into height, the formula. So half base is 10 and height is 0.83, which is nothing but 5 by 6. So we can cut this. 2 5 are 10. 5 5 are 25 by 6. If we divide it, it will give 4.16 meter. So what does this rule mean? That when the brakes are applied, after applying the brakes, car A travels 36.11 meter and car B travels 4.16 meter. So which car travels farther? The car A travels farther after the brakes are applied. Yes, it stops in 5 seconds, but during this 5 seconds, it travels more distance. And car B, its velocity is its speed is very less, and so it slowly stops. Okay, so during this 10 seconds, it's covered only 4.16 meter. So this is how the interpretation of graph and is done, and this is how the graphs of the motion can be drawn. Very important question. So refer this question, write in your notebook, draw this graph in a graph paper. Okay. For this question, you have to draw the graph in a graph paper. And still, if you have any doubts, you can ask me. Thank you.